Okay, think we're live. Hello everyone to another day where we do nMage or actually Flappy Bird today. So open up the stream. All right. So I know we are not on schedule today. That's an extra stream I wanted to do since we were doing pretty well with Flappy Bird and I wanted to make some progress. Right, so let's look at what we did since last time. So now we have Mr. Flappy Bird going, I think, pretty playable positions and speed for the birds. So I don't think there is something where I cannot reach it or I cannot win it. Yeah, so even between high and low, acceleration is nice and all. Okay, so this is nice. What is left for us is really, let's see, we need scoring and we need the ability to lose. So as we pass a set of pipes, we need to increment the score, and also if we touch any pipe or we hit the ground, then we lose as well. So to do this, we need some kind of collisions, and yeah, we don't have that now, so don't have physics system, but just box collisions are actually pretty easy to do. So let's go and let's open up Paint. It's the Paint. All right. See if this works. Yes, it does. Okay. So if we think about it, right now we only care about boxes, so we don't have circles or anything like that. Maybe the bird can be a circle. Yeah, it's okay. So if we have a box, and sorry, the lines are not straight. So how can we define a box? Well, for sure, everything has a position. Maybe we can define the position from the center here, or we can define it, for example, from the bottom left up to us. And then from that point, we have, if it's from the center, then we have half the width. So this is W, this is H, and this thing is each side is W by 2, and this thing is H by 2. Right? And then with this kind of definition, if we have a box and we have another box, and the idea is, are they colliding or not? Well, we need to look at the extremes of this box and see if they intersect. So for each, there is a formula we can look at, but essentially, even if we do right now a stupid way, we can, using a center and the width and a height, we can get these 4 points. So maybe x1, x2, x3, and x4. And here maybe y1, y2, y3, and y4. And if on the x, for any point of this rectangle, if they are, so for example, x4, we are checking it. Is x4 has an x and a y. Is x between y1 and y2 on the x-axis, right? It's between basically the center and the width. If it's in that range, between these 2 points, and on the y-axis, it's also between this range, then we have a collision, right? But I think a better way to define this is to actually position the box bottom left. So like we define it from here. That's how our box is defined. And then we simply have width. We have height. If you want the center, then you just take half width, half height. So our box is between, what do we call this? Between, let's call it the P. So our box is between, if I can write today, between Px, Py, and Px plus H or plus W, and Py plus H. These are the two kind of extremes on the bottom left, top right. If you fall anywhere in that range, so if your X is in between these two values, and your Y is between these two values, we have a collision. And so I think we can go ahead, start implementing. So we need a way to define a collision box around our quads, which should be easy. Maybe a way to visualize them, and then we just need one function to check basically these data points. Now let's look at box collision, 2D box collision. Let's see. So right now we don't care about rotations, so we'll only use an AABB, which is an axis aligned bounding box. The box, as you see, like the idea is, even if the actual thing rotates, the collision body never rotates. You see, when the body A rotates, the box around it gets bigger, but we don't rotate the collision. Makes it very simple to do collisions. So yeah, there we go. So here they're defining it from top left as x1, y1. So this plus width and height, and then they just check, hey, is this thing, is x1 plus w bigger than x2, and so on. Just a bunch of rules, and that's it. Min y, this is also, I like this name, min x and max x. Yeah. Okay. So let's go to the code. Where do we start? Let's see. So in the quads, first I would like to have some collision quads. Let's see here. So one thing I added since last time, a small thing, is just an outline. It's basically a transparent texture where the edges are white. That's it. We just use this to outline kind of the collision boxes, to visualize them. Okay. So where should we put this? Where should we put this? I just put it here for now. We're dealing with quads anyway. So we have, what do we call it? We have collision box collider, right? 2D, oh yeah. Box collider, 2D. Collider is too long. It's okay, for now I'll keep it. So maybe we'll define it as min x floor 32, min y. So min x, min y is bottom left. I think this makes more sense. Or actually, let's just do x and y, and then width and height, and that's it. These two are bottom left of the collider, and that's it. Okay. Now, what else do we need? We need a quad, I think, to visualize it. So why not combine it for now? So let's embed a quad in it. And then maybe we can have, let's move this down. quads here, and we do func new box collider 2D. Give you back a box collider 2D. Right. So first, what we want to do is call new quad. Let's return new quad first, and sprite name box collider 2D. Sprite path. Well, for the path, I want the white outline PNG. Yeah. White outline dot PNG, which would give us error, Q, and error. For now, I'll just panic. We should always have this. Panic, fail to create box collider. Okay, and we return this guy. Our quad is Q. X, oh yeah. So we want a starting position, perhaps. X, Y, width, height. And why not? This height. There we go. Now, let's have our, for example, so bird box collider, right? And this thing is a quad box collider 2D. Then let's load it. Quad dot new box collider 2D 0 0, and well, right now the positions are exactly the same as where the bird is, but in a physics system these are potentially different. So where the physics system thinks the object is and where the object is visually might differ, right? But for now, I think this is okay. This is okay. All right. So width and height, let's keep it at 1 right now, and then we do bird box collider. Okay, now let's draw it. And one thing really is setting attributes. We keep setting them every render, but really all this does is it enables the attribute and sets some information, offset, stride, so on. These things never change. So how do we? They all share the same attributes in this case. They're all quads. You don't really need all of these. That's okay. Yeah, it's fine for now. Okay. Draw the bird, which involves the bird itself and the bird collider. Bird mesh, which is the same, doesn't matter. And the bird model. So the position, since we're embedding a quad, it already has position. No. Wait, I'm a bit confused. Where did we have the positions last time? Oh, in the pipe, but then the bird as well. All right, we did entities. And the quad embeds an entity. All right, I completely forgot. Okay. So, maybe since we already have position X, Y, Z, we don't need this. Let's see, because now we have two kind of positions, one of the entity and one of the collider. Yeah. In our case, the entity would probably just follow the bird. And then we have these guys. Let's see. Okay, for now, I want to draw it. Which should be enough, maybe. Just to do this. Okay. For now, we set it ourselves like this. So position, read write, and what we want to do is. So I updated also ggLM. So we have a few more functions to work with on vectors, add x, x, y, z, x, and so on. Just more Swizzle operations, including adding. Okay. So if we are to follow the bird, then what we want to do is set let's set everything to wherever the bird is. Bird sprites dot position read. So bird position x dot y and dot z. And dot z, and let's increase a little bit just so it shows on top of the bird always. What is the issue? System cannot find it. All right. This is not a model. This is in textures. Awesome. So we have this bird, this box following the bird. The scale is off, so we need to set the scale, but otherwise it looks good. Let's scale it up, or maybe down. So bird scale reads, right? And bird box, no, scale read writes. We can just set it in this case. Bird scale. And set it. That should do it. Cool. So now this is has exactly the same position as the bird. Now, potentially from the position, we can calculate x and y instead of letting it be set by the user, which might make more sense, really. Since it always follows the object, it can be centered, then x can be calculated from, the center minus half width and height. Yeah. Yep. So I don't think these guys make sense. At least not like this. For this, it's kind of hard to see. So I want to control the color of the outline. So let's go to the fragment shader. And right now we are just looking up the texture color, and our fragment is, so the pixel is just exactly the texture color. Let's have a tint. Let's add a uniform like this guy and say tint color. By default, it's white. It won't affect anything. And so here we can do text color RGB multiply by tint color, and then the alpha value we can just keep it whatever the alpha value is. This is tint color. So when we draw it, what we can do is simple math dot uniform set uniform back3 tint color, and we want it to be let's say green. Usually colliders are setting green, like at least Unity does. We draw it, and then we can reset the tint to all ones. What's happening? Okay. Oh, it's sorry. Set red RGB. There we go. This is nice. And obviously we can put it on the pipes and so on. But for now, let's focus on the bird. Just get the collisions working. Okay. Let's have another one. Let's have another one for the pipe so we can do collisions. Now, if we go to pipe. Where's pipe? Go. So pipe is a quad, which is an entity, and we can instead it doesn't actually make sense to have a texture on the collider, just a position. Should we make it an entity? Yeah, just an entity, not a quad. New entity, entities, new entity. And why is that? Yeah, for the visualization, it's okay. I don't like the structure, but I think we leave this for later. Like when we implement it, maybe in nMage itself, because here everything is getting mixed a little bit. Wow, and that's another bug we need to fix. So it's okay. Right now, pipe will have inside of it quads.box collider 2D. It's called call. Then collider is what do you call it? Quads.new, this guy. Okay. So as we have pipes with us, what we can do when we render the pipes, we can render the pipe, and then we can render collider mesh. And let's see. Is this enough? All right. We need to do something similar to this. So pipes collider position read writes, it's going to be set it pipe position is what's read x, y, and z. But the z is slightly up. Same for the scale is exact. So this is fine. Oops. Scale read writes is equal to scale read. This is not scale.collision to scale. Then you can come in and say this. Where are they? Can we just not see them? Pipe. Same scale, same this. Well, we also want same rotation. Just to do this. And then collider mesh, yes. Collider model mats, simple material. All right, we need to set the texture. The mesh should be fine, but the texture needs to be set. So maybe we'll have another loop. We'll do it twice. So draw pipes, draw pipe colliders. By doing this, and then before it, they're all one texture, so whatever, collider, the text ID, and just to be safe, do this. There we go. Okay, so they're a bit stretched, you can see, but we have, without a tint, we have the colliders there. Let's color them. Let's do some coloring. What should you do? Well, green will blend in, I think, too much. Yeah, maybe. Oh, you need to reset. We're tinting everything now. We're tinting the bird. Let's make it blue. Blue is different enough. Yeah. Okay, so if these two guys touch, that's what we want to know. Does what we want to know is the bird collider colliding with any pipe collider, right? That's the only possible collision we have right now. So in the logic, after we do everything, maybe we'll have call a function func check collision. So let's write this info. Just to check. Now, I think, I'm not sure, but we're drawing things from the center. Or is it from, like, when we set a position and we set it on the model matrix, I assume this is the center, if I remember correctly, right? Because in the model space, like in Blender, you draw it around the origin, and so it's centered, yeah. So we might have to use this kind of model, or we just calculate x and y, right? So on the box collider, we'll make these, for example, we can make these private. The scale affects this, but then what's the size? Yeah, these are private. So x and y. And we want to do this guy get what left returns vector. So we can return b.x. Actually, no, not directly. So what is x? Assuming quad, so like b dot position read, right? We have this. This is the, if this is the center of the quad, then what we want to do is move half to the left. Yeah, I'm a bit confused about the sizing. Maybe you can draw something around this. I want something to visualize the positions we're talking about. Well, before this, just do this, which is wrong. Let's draw a bird again. Bird collider. Let's do this bird. So I'm just going to draw a bird again, but what I want to do. So let's get the original, just to maintain everything. Orig model math. Get a copy. Okay, and then or let's do original position. Let's read dot clone. It's already cloned. Scale. Scale rotation, we don't care, it's already set. So then what I want to do is play with the position. First of all, we'll say that the scale read write set scale is exactly 1 on 1, and position, let's set it at we'll keep the z is fine, just so it shows on the camera. Let's position at 0, 0. Right, we draw, and then we can set them again to the originals. Original position. Oh, it's already. scale. There we go. It's okay, so we can see it's exactly centered. I don't think it's offset. Yeah, I don't think it's like offset from the bottom left. So our center right now for a quad is exactly the center. We can test this by scaling it, let's say 4 times. If it remains centered, then otherwise it will be offset. Yeah, it's exactly center. So our 0, 0 is the center. And what we want to know is essentially the width and height. Yeah. Okay. So our x is the position minus half the width. Our bottom left is position minus half the width, and then position minus half the height. Well, I actually forgot how Unity used to do this. If I were to get some inspiration. Unity Arial, you have a size independent of the, you have a collider size independent of the scale. Right. You have a size and an offset, yes. An offset from the center and a size for the thing, which gets multiplied by the scale. Makes sense. So you have the position, which in our case, the position of the bird. If I were to, right? So as an example, and it's good that this is also a 2D thing. So we have a position, in this case, position of a bird for us. And then we have a collider on it. And the collider has an offset from the position. It has a scale and then a size in units. Now the size gets multiplied by the scale to get you the final kind of the size, and the offset is from the center. This for us will be from the center. So our bird, yeah. So for us, that's why this width and height are important. And then bottom left is, let's see. So we need with our position, or let's call center to be exact. Position, b dot position read, and should we care about the scale? Yeah, we do. B dot scale read, right? So x, our bottom left, is the center minus half the width. So minus b dot width divided by 2, right? All of this, I believe, is multiplied by some scale on the x-axis. Okay, and then lower y moves down for us. So yeah, so we also minus, let's copy this, but we minus by the y, scale on the y-axis, divide by 2 height, and this is our y. Oh, it's not b dot x. These things are not needed right now. This thing is position dot x and position dot y. Cool. So let's print bird box collider dot get bottom left. And can also say position I think this is well, let's see, position string. Okay, so we know our width and height are 1, and so we should be offset by half. So here is our bottom left, and then we print our position, right? Our y 0.8 by half is 0.4. Yeah, it's correct. So this is our the ordering is confusing. This is our position on the y, for example. Our y scale of the bird is also 1. So the scale doesn't matter here. We just have 0.35. That's our position. Minus half the height, which is half, right? So 0.5. So 0.3 minus 0.3 minus 0.5 is 0.8. You have the 001 here. Okay, so we are calculating now our bottom left. Very nice. We have our width and height. Should we we can make this one function extends, so bottom left, and yeah, let's get extends, I think they're called. Let's give it clearer. Get bottom left, and then let's get top right. And let's return, honestly, a vector. Vector 2 here and here. New vector 2. There you go. Okay, in this case, I think the only difference is we just add here, and that's it. So now we have our bottom left and top right of the collider. Now we can check collisions, I believe. That's about it. So in check collisions, and we don't need our test bird anymore. Check collisions. Right now, let's focus on one collider, one pipe, sorry. So when we draw the pipes, let's do one thing. Let's color one of them red. So we draw from pipe 1, and then let's have this. 0, 0, 0. Okay, so draw pipe colliders. First pipe collider is red. And then we start at 1 and we draw the rest. Here, all we do is give it the right color. There we go. So our first guy is red, and then after a while we should see it loop back, because if you remember, it goes out the screen and then back the other side. I'm losing a lot here, but there we go. This gives you an idea of like everything is looping. We're not generating any more data, even for an infinite game. Okay, so this is good. This is good. Now let's try check collisions. We'll just care about first pipe and the bird to see how the check is done. Anyway, so let's get the bird collider, get bottom left, and collider is just wrong. This is logic, right? This kind of logic should be moving the collider with the bird should be done not in draw. There will be a frame late detecting collision. Yeah, so this guy here will just handle drawing. Sublet. Move the bird, and then we move bird collider. There we go. And just to confirm, we have no delay or anything. Should be, yeah, this is perfect. Okay. Now, bird bot left is this, bird top right is top right. Maybe you can simplify the names actually, just say bottom left. What's wrong? Has errors. Okay. Right, and then we say pipe top right, pipes 0 dot top, and pipe bottom left. Okay, so now we have this, the actual collision logic. So we have the 2 points. We just need to check the position. So if any, so the collision happens if any of the 4 points are inside the other box, touching or inside, right? So we need to check each of the 4 sides against the 4 sides of the other box. Let's see. One more thing I want to do is bird X range. Does this make sense? So if it's between this and this, yeah, this is in the FC. Okay, so if the should we make new vectors for this? Maybe. Let's have this. Let's have all of them. Bottom left, bottom right, and then top left. So bottom right is nothing more than bottom left plus the width, right? That's it. So it's this cloned, but the X position I think there is a more efficient way. I mean, this works, but where we have four points essentially, and we just check these points are intersecting. Let's see. Yeah, this is essentially the trick. X and Y in width and height, and green means collision. Yeah, and the collision is if the X position, and here do they mean center or not? Not sure. X, Y. Need 4 checks. Yes, so this looks like one of the edges. So if first rectangle dot x is smaller than x plus width, yeah, so these are the positions. We don't need all of these. So if let's check the bird against the pipes, right? So if the bird dot bottom left dot x is smaller than it's between essentially the two x positions of the pipe. So if it's bigger than what do you call it? Pipe bottom left dot x, okay, and is smaller than pipe bottom left dot x plus smaller than or equal to. Should an equal be collision? Yeah, I would say so. Here they don't. But yeah, let's keep it this way. Okay, plus pipe width essentially. So we'll get pipes 0 0 dot collision dot width. Right. So this check is we have this box and we're looking at let's say we have these two boxes. This is a different color, maybe blue. So in this case we have a collision, but the only thing colliding is this point. Right. So how do we know it's colliding? This is x, xy, and this is here is width height, right? This point, if its x position is bigger than this x, and this thing is x plus width, right? If this point is bigger than this x but smaller than this x, then it's then in the range, right? So we have something. Then we need to check if it's within the height, because it might be in the same range, but it could be here. If it's here, there is no collision. So let's do if this thing and and the y position of the bottom left, if it's between, I think similar thing, if it's between, it's bigger than this thing and heights, right? Yeah. So if so here we're checking if the bottom left is within the range. If that's the case, then we have a collision. And then if y is bigger than and it's less than that guy's height. So x is within this. If it's less than this, the width is less than this. I think I'm missing something. As in the most efficient way. Okay. I mean, this will work, but it will be longer. Here we check just one point. We're checking a point inside a rectangle, which is enough if you're checking point collisions. But what we want to check is box against box. For them, they're doing if x is less than the essentially right of the rectangle, okay, which is this side. X is less than the rightmost side, and then so if our left side is smaller than their right side, so we're comparing our left side to their right side, and then we compare our right side is more than their left side, and then our same thing for our height. If our bottom left is within this and this, then I don't get it exactly. Circles are fine. There's no gap between any of the four sides. Well. Let's take this and then understand it in a bit. It's been a long time since I looked at these collision algorithms. Okay. So if x, so instead of trying for a point, let's treat them as full rectangles. This is our x and y. This is x plus w, y plus h. Right here, the only difference is x plus w as well, and here it's y plus h. Now, first thing is, let's say the blue one is rectangle 1. If our x is within, so this is our x, it's less than their x plus w, which is correct, right? So this side is within that side. And then they say, essentially, if their x is also within, so if we were to write this, maybe with better ordering, our x is smaller than the pipe top right x right? Which is equal to plus W. And the pipe, let's see. And the second one is if our right side is bigger than, in this case, this is true. Our right side is bigger than their right side. This thing is our right side is bigger than their left side. Sorry, their left side. Which means if pipe bottom left is smaller than our bird top right. Top. Oh wow. Forgot to change this. Top right. Right. Okay. Bird top right. Dot x, which is this guy. So if their left side is smaller than our right side, our left side is smaller than them, and their left side is smaller than our right. Yeah. So we have these two are correct in this case. So our left is within our left side is smaller than their right side, and their left side is smaller than our right side. So both of these are checked. Where is this? This guy. So their left side is smaller than us. But then I feel like if this goes on the other end, no, it still works. Okay. So this we did. And then what do we have? Bird y. So that's the bottom left dot y is smaller than pipe top right dot y. Right. And lastly, bird bottom actually pipe top right dot y. No, pipe bottom left dot y is smaller than bird top right dot y. Right. I hope this is correct enough, and then we can say print line collision. Let's see this does. So far so good. Okay, now let's wait for it to come back because we're only checking with the right collider right now. There we go. Let's collide. Nope, that did not work. Weird. So bird is smaller than their top right. Our y is smaller than their top right. Yes, and their bottom is smaller than our top. Yeah, these look fine. Check collisions. So one thing is we are moving the pipes here. This movement should be done up there. Here we just drop. Get the pipe position, scale, rotation. That's not for here at all. So we move the pipes. Well, so here, this is the normal movement if we did not kind of loop them back. So in this case, we just need to set the position exactly. We just need these two lines. Scale and rotation never change. So we really just need these two. Get the position and then set this. When they're first created here, we can set scale or rotation. So by position is just P, and then all of these is P, P, P. There we go. All of these, and then same thing here. Top pipe and its collider. Here we have the bottom pipe. So we have these things set here, and then in update we only change positions. So these two are enough, and sometimes we jump around, and so we can do these. We can do there we go. So by the time we reach drawing, everything is updated. So we don't get collision still. So we do all of these. We make sure the bird and these colliders are moved, and then we check collisions, right? This could be wrong somewhere. Let's look somewhere else. Collision detection. So these are the four. So our left side is to the left of the right side of them. Our right side is to the right of their left side. Our top is above their bottom, and their bottom is Well, let's go back there. Although here it says y is the top, and this is x, so it might mean they're taking the top left, not the bottom left as we do. So that means when we say y here, we actually need to minus the height. But let's go with the meaning in this case. A's left side is to the left of their right side, which is what we have. This is our left side, or x is less than their right side, yes. And their lefts is less than our right. Also right. Okay, then it's in the height calculation, I think. And we can check this. X collision. I think this will come out true, but because the y is inverted, not the x. X collision false, true. There you go. Nice. Yeah. So this is fine. So they are actually talking about the top left. Top left here is this check is wrong. So here the check is our minimum is less than their maximum, and their minimum is less than our maximum. Right? So there is some overlap area. Essentially, we're talking about this area, right? This is where the intersection is happening. Their maximum, where is this guy? Our minimum is less than their maximum. This is our minimum. It's less than their maximum, yes. And then their minimum is also less than our maximum. This guy. Now, vertically speaking, we need, what do we need? Our top is above their bottom, and yeah, our top side. So where's our top side? Our top side, this is our bottom side, is above the minimum. Yeah, we have this reversed. So our top right is above their minimum, which is the pipe bottom left, and then their minimum is lower than our top. Yeah, it's lower than our top. Now we should see proper collisions. Just we have nothing here. Did that not work? Oh wow. Again. A's bottom is lower than B's top. A's not the pipe, the bird. bird's bottom is lower than the pipe top, but our top is above their bottom. Yeah. Wait, what? Why are we still not planning? Top right of the pipe, bottom left, pipe. Top is less than or is more than. Yeah, to make sure everything is, I just want it to be everything smaller than. So their bottom is less than, is lower than the bird's top. Yeah. The bird's bottom is because they're bigger and smaller reverse to us. They're the opposite. They are the opposite. So when they say a dot y, they mean the top of a. It's less than this plus height, because for them height is going down. A stop is above this bottom. So a stop is above, in our case this is bottom, and the bird's is bottom. I mean, these look heights. Let's put them in now. Print line. This guy. Print line. There you go. So this one's always false. This one's always false. Let's just check this, make sure it's correct. Top right is moving up in Y, moving this. Bottom left is moving left and down. This one is right and top. Oh, potentially the. But do you consider that? the rotation might have affected it because of the pipe. So if we have two birds colliding, I think that will work. Maybe. Because for us, our bottom should be less than their height. So it should be like this. This is their top. This is our bottom. It should always be less if there is an intersection. We're either like this, we're here, and this is again our bottom, right? If there is an intersection, our bottom is always lower than their top. If we are higher, then that's it. But for this to work, you cannot be rotated. If your bottom is above their top, then there is no collision. So it must be less than the top, right? And then your right side should always be more than their left side. So you are in this range, because if it's less, if your right is less than their left, you cannot have a collision, so on. So in this case, our bottom is being less than their height. How? So let's forget this guy. Let's show the pipe and the bird. Let's see. But it could be because of the rotation. So pipe is on the left, bird is here. This looks fine. $13, what? 100. And it became 78. It's huge. I think the scaling is an issue. I'm not sure if the rotation. So let's not rotate our colliders, because for us it doesn't even matter. Just make sure. Rotation, no. No. So the next one is at 125 for the top. And we need it to be, we want to be, its bottom is 200 something. Yeah, this is the rotation. This is the rotation, I think. Because 100 something is the other end of the pipe. Why is that? What's the scale? So the scale is 10. So that's why we're getting so high. Should it be multiplied by the width and height instead of by the position? Yeah, doesn't matter. So like, instead of multiplying by the whole thing, multiplying the position by 10 as well, we multiply the width. Yeah, I think this makes more sense, not the answer. What we do is this. I believe so. You don't really need these brackets, but it's okay. It's nice to just be very clear about these things. The scale is being applied incorrectly, it seems, giving us huge values that we can never match. So multiply by the scale, and so on. Okay. And then maybe this will work. Maybe. Come on. Ooh. Oh, dude. You're really telling me that our top is higher than their? So we say our top should be above their bottom. Yes. Okay, so our top should be above their bottom. Okay, meaning basically is their bottom is less than their top, which is fine. But then is this always false? Is this what's happening? It's still happening. Yes, it's always false. Oh. Do I have to reach the mid of the pipe for it to work? What? If I go a little bit higher, it works. Top right. Width. Okay. Going up from the center is position y plus height into the scale divided by 2. Yeah, I already had these brackets. Let's do this. When it's all multiplication, I find it easier to read than adding divisions. Oops. Okay, let's show. I want to know three things about the bird. Or about the pipe really. The pipe top, the pipe position itself. So pipes 0 dot position. I think y is enough, right, for everything. Y and the bottom. Pipe bottom dot so our position is 8.2, top is 13, and bottom is 3.2. With I think a width and height of 1. Is it? Yes. 1, 1. Now, 1 into 10, I think. Yeah, so our scale is 10, but we move by half. Scale is 10, so width and height are 10. No, sorry, we're talking only about the height, so scale on the y is 10, and we move by half. One time up, one time down. So half is 5, one time up gives us 13, one time down gives us 3. Looks good, actually. Looks okay. What about Mr. Bird? Birdie. It hit a collision, actually. Okay, the bird's new position, and then we update the collider alongside it. Okay, so where is the bird when we had the collision? We got a few frames of collision. Is it working now? What with that? I thought we passed it last time, even after fixing the scaling issues, and it didn't work. So, what's going on? Yeah, we didn't hit it. So we have to be kind of high, really high for it to work. Yeah. We have to be around the middle of the pipe. This is what it seems like. So again, it's telling me that there is a why am I disconnected from chat? Cool. There's some scaling issues, I believe. One way we can test this is if we unscale the pipes and we try. So where is the scale? Pipes, scale. So let's scale the top. So pipes, I hope we can still see them. Maybe. At least sometimes. If it's positioned lower, we should be able to see it. Come on. There we go. Yes. This was a nice collision, yeah. There we go. Let's try it again. No. We touched it on the edges, but didn't collide. You have to be almost inside. That's so odd. I don't get it. Are we missing something? AY is smaller than. So this is all in terms of A, which is for us, you can see the bird. AY is our bird. Top, the middle, and the bottom. And our coordinate system does move down when we do it right. That would be a very sweet mistake. When we create the pipes, yeah, we do a minus for the bottom pipes. Then the bird velocity, drag, and then gravity is negative, I believe. Yep. Where do we create the bird collider here? 1 1. A bit confusing here. Because this looks good. Unless someone has any ideas. Let's see. FB, and we know we're doing this after the positions have been updated. So move the pipes. Read lines. Rendering, we just call this, we don't do anything special. Yep. But then even when we scale it down, so assuming scale is not an issue, it's still broke, which is really interesting. Bottom left is just this. It is width, half the width, and we're scaling. Okay, let's just see at least once all the information about, say, a pipe. So a pipe So I want the position, right? Okay. That's wrong. So I want pipe position, pipe scale, and then rotation shouldn't matter. But then let's say bottom left, top right, straight. Okay. Position is this. So it's positioned at 9 vertically. Okay. And then scale of 10. Otherwise, um, now what do we have? Bottom left. So scale is 1 and width is 1. So you move by half, right? So minus half on the x. So it becomes minus 7.1, which is correct. And then we have 10, which is 5. We move down by 5, which we get 4. Okay. At least I assume these numbers are right. I mean, they are right for the calculation we did, but the calculation should be correct. Okay. And then this is the top right. Top right increases by 0.5 as well, which is fine, and increases by 5, so the 9.3 becomes 14.3. These look good. I don't say these look good. Let's do Mr. Bird. Mr. Birdie. Okay. So a bit less than 1.75 is our X change, and for our bottom left, we move by half of 75, yeah, which is 375. Okay. And then on the Y, we move by 1 downwards, which is 2. We move by 0.5, sorry, which gives us 2.9. And then moving up, we move again by 375 here, which looks good. And then 3.46, we move by half upwards, which becomes 3.9. These numbers are fine for both the pipe and the bird. These are fine. One thing is I do want to limit the frame rates because it's a bit too much when we want to check logs, essentially. I want to run in slow-mo. Slow motion. Maybe in each update, all we have to do is we sleep, we increase the delta time, and then everything just moves a lot more. Well, I'll just run the debugger and then I'll raise the breakpoints. That's fine. Come on, friend. Come on, friend. Okay. So we did hit a collision actually. But only after a while. So this is our situation right now. But it could be a very tight situation. Okay. So bottom left is -5. Okay. And their top. Wait, what? Pipe top right. Our left is -5. -5.3. Their right is -5.6. Really? I mean, it's close, but yeah, I guess 0.6. Okay. Looks fine. So this check is correct, I guess. So it seems. Okay. Now, the pipes. Pipe's left side is -5.3. Wait, this looks wrong. Okay. -6. Yes, it's more to the left than we are. So -6. Okay. Looks fine, yeah. About 1 unit more to the left. And then the bird's right is -4, yeah. It's more than this guy's right, which is -5. Okay. We go again. Now, its bottom should be, just tell us for sure, it's at 3. And we are at 9. It's lower. Yes. Our top is higher. Is it that far? Yes, this is actually far. Turn 6 units, so this is also okay. And then finally, the bird's bottom Y is 8. Bird only has 1 unit between its top and bottom because its top is 9 and this is 8. Yep. But the pipe stop is like 13, somewhere completely different. Wait, what happened here? Y is 8. Yeah. It's 13. It is less. What? Wait. What the hell? This was why. Okay, let's move one more frame. We should still be in contact. Yeah. What the hell happened here? Bottom left Y. Oh wow, what the hell is this? Minus 2181696. What? What is this? Is it just the debugger being stupid? Oh my god, no. I think we had the big move. We moved a ton. That's why. Where things disappear. That means, are they disappearing like vertically? Well, both sides. Yep, they disappear. Everything's broken now. Well, this was weird. Because it failed on the last check, even though I remember it. I noticed it's good. At least I thought so. Okay, let's try it again. Okay. So is this giving us where did the window go? Anyway. Are we getting collisions or not? So it seems we're not getting collisions. Last time we did get, this time we're not. Okay, even though we know we're inside, so let's see. Bottom left of the bird is -5 again. The bird X never changes. And then top right of the pipe is -4. Which is right, yeah, but a unit. Bird's almost there. Okay. And then the pipe's X, bottom X is -5, and then the bird's right is -4. So the bird is inside, right? It's bigger than this guy, which is required for collision. Good. Then this guy. So the Y, the bottom of the pipe should be less than our top. So the bottom here is 8. We should be like 9, 10, maybe 6. What? Bird top. This will fail the collision check now. Our top is clearly up. It's clearly bigger. Makes no sense. Oh no, it's actually, sorry, yeah, I was confused. No. Its bottom of the pipe is 8. Okay. But the bird is saying its top is 6. No way. Yeah. So wrong. You can see, yeah, our calculations are going off somewhere. Let's look at the, so this will fail here, as you can see. It won't even go to the next check. Yep, it failed. Let's go to the variables at the top and look at the bird entity position. Can I just drag them? This is really bad. Okay. Can you please watch window, Mr. Where's sprites? Not entity position. There you go. Dot position dot data. Okay. Cool. So here's the position minus 5x, 5.8, which gives us 6 on the top. That's reasonable, I guess. So again, the pipes are potentially screwy. Pipes 0 entity thing dot quad entity dot position dot data. 13. So 13 is the center. I assume 13 is the center, is it? And then you move 5 down and you get 8. Something is wrong. So if we go to resources, textures, this is the pipe. And if we just load it without scaling, it turns out tiny, this, and yeah, should follow the same things. Yeah, -5 gives us a like a pipe bottom. This is an 8. Yep, 8.03. I don't get it. So if that's the case, we assume everything is correct. Then how come we're higher than? How is that possible? Okay, I think we need to do some experiments to understand how the positions are being handled before we do collisions. So let's come in. We'll do a similar thing we did with the bird, which is a test pipe. So if we have a test pipe, let's take this, right? You can say if test pipe is null, we can just do new pipe or something. Yeah. Let's try. Let's put it at the bottom for now. Ah, come on. Okay. So our test pipe is going to have a scale of, right now we'll do 1, 1, 1, and a position, just to make sure that nothing has been moved, of 0. Except, yeah, I'll just set it on top of everything. The Z, otherwise, it's this. And then we draw it. Right, then we draw our own pipe. There we go. Now this fancy pipe, which looks weirdly stretched, but whatever. I want to do print test pipe.collision, and unfortunately we have to do the collision by hand. Well, test pipe dot position read write set 0, 0, 3.1. Scale read write is okay, so it matches the pipe, and now we can print what the collision of the pipe is. Then we'll see where the breaking point is, like where does the visual position does not correlate to what we expect. Now we know where the issue is, because it could be that we're misunderstanding the visual location, like where, how OpenGL is translating it to a position on the screen. Maybe. Anyway. Okay, so let's get the position. Not the position. Bottom right, bottom left, and then top right. You can see, by the way, it's exactly centered, and it should be 1 unit width and height. Yeah, so we get minus 0.5 as we expect. Yeah, it's at 0, and then you move halfway each side. Now the question is, does it matter if we draw another thing? Oh, we're drawing it so many times. Just need to draw it once. I want to do a just in the bind. Yeah. So I want to draw it, and then just to compare, let's draw the bird again in the center. The same position as scale, bird sprites, text ID. Mesh is the same. Position is the same, so the same. Just the texture is different. They should exactly overlap. Maybe. Yeah, I assume they're overlapping. Let's do test pipe dot position read write set Z to 3.2. Yeah, we could just see it for a frame. What do you call it? Yeah. So it's exactly the same size. We can see the place where it's transparent. We can see the pipe behind it, but yeah. So the scaling so far is exact. So far it is exact. So here, this is our test bird. I'll disable it for now, but we know they have the exact, like when we say one, it's the exact size. When we say it's 1 unit, or we have a 0.5 bottom right, it should match as expected. Now, let's say we have a top pipe. Does this continue? Yes, it does. Bottom left and top right are the same. Look the same. Okay. Now let's scale it up. Scale it up. Double. Scale. Scale. Okay, so we have also double the height. They still match, I think. -1. Yeah, so it used to be 0.5. It got doubled here and doubled there. Cool. Was good. Okay. What about 10? Yeah. Okay. These are all good, honestly. Do we change the scale somewhere else for pipes? Is this what's happening? We set it at the start to 10, 110, 1. We don't. Okay. For this, let's make, I want this to be, is colliding A and B, and let's just do box collide. Oops. Let's move this logic here. So we can reuse it when we're testing. Is colliding, and then bird this guy is B. and then return just a bool. Why are you sad? News, sure. So if is colliding, bird, box collider, and pipes 0 collider, collision, we don't need all of this. Now that we have a test bird and this guy exactly matching, they should collide, right? That's what we expect, is colliding, and we'll just see. It should collide with itself. That's one thing. Yeah, true. Okay. Okay, let's move them now up somewhere. So we have, if we move them up by 1, now they go outside the screen. Does this affect anything from the positions we expect? Okay. Wait, 6? Don't get it. So it's positioned at 1 now. -5 is -4. Okay. Yeah, and then +5. Yeah, that makes sense. Okay, instead of a pipe, let's test. So rotation doesn't affect position scaling. Seems to work fine. Let's just do call 1, call 2, which is a quads collider. New collider, 1. Okay. Now call 1 can be position read writes dot set zero zero zero. Just do a 1. This guy, let's move them. Let's move it 1 x, so they should exactly be touching the edges. And then the scale should be the same. Okay. For now, I'll just do Okay, and now to draw, we can just repeat the draw command here since we already have the birds. Okay, this is a bit easier to work with to test. Oof, something died. Oh, we're binding the pipe and whatnot. Still, bird box collider. Yeah, what's the issue? We have this tent, and then do we unbind anything? Don't think so. Well, let's do what's wrong? I did wrong. 332. Yeah. Sod. Well, let's just use. Could be a bug in this. Don't see these guys. Position. So we don't 4 on the Z. So they actually appear somewhere. No. Well, it works like this all the time. Wow, it's already been 2 hours and a half. Damn. All of this on collisions. Come on. It should be easy. It's AAB. AABB. Ready? Okay. So let's give a tent here. We do this and we do the reset. Let's do red or green, blue. Okay. So yeah, the colliders, we set position scale of each, and then print them. Let's do for both. Okay. We set the tints, we set the texture. Mesh shouldn't matter, they all have the same mesh anyway. But sure, and then we bind, which updates the texture for us. No, we draw it twice. What's that? What else? Why is that? Why are you and you need this. Finally, okay. Did we change the scale of one of them? I like how it says they're not colliding. Scale 1111. No, we did not. Okay, let's put them in the same place for now. Okay. They're colliding. Okay, cool. Let's move it by 1.1. This should break the collision. This is weird movement. What? Oh, the hell? So we're drawing at a scale of 1. But they're being drawn as 2. Is this what's happening? What's the size of the bird? What's Mr. Bird? Mr. Bird is 34 by 24. Maybe it shouldn't matter much. Scale 1. Size of 1. If I move by 0.5, we should be halfway separated, exactly. And then if we move by 1, we should be touching the edges only. Then if we move by, I don't know, let's move by 1.1, we should not be touching at all. So something is wrong here. So potentially with the outlines and not with the, yeah, they're still not separated. What? Okay, show the positions as well, just to. If it's this bad, then no wonder it's not showing us collisions. What's wrong with you? Come on. Read right. Finally, they separated. So if I just move 0.1. It's moving a little bit on the right, but we should see the other cross on the left side, but it's not. Is it moving unevenly or something? Makes absolutely no sense to me. So I wonder if this is clear to everyone, but we essentially have 2 boxes, and again, I apologize if they're not clearly on top of each other. They're exactly, let's imagine these are actually on top. They're on top. And so if we move one a little bit, so let's say the blue one was moved to the right, so we should see a cross here, right? And then another line here. So we have 4 lines, aside from the top bottom. 2 to the right, 2 to the left. But what we see, and here I have moved it, one is positioned at 0, one is positioned at 0.2. Let's even move 0.5. We should see 2 lines. We only see one. We see the one on the right. Is it not being considered as transparent? Is that what's happening? That would be weird. Doesn't make sense actually. They should be transparent. So why are... I don't know. Let's move one on top. Yeah, now finally. Oh god. Yeah. So and they have a scale of 2, which now makes sense why all the calculations are wrong. Why are they scaled to 2? Are they? Oh no, wait. I'm stupid. Yeah. Think no. So we move them by 1, but we only see half. So their size is 2. So if we move by 2, now they're only just touching barely. Yeah. Touching at the right edge. And if we move by 1.1, we should... I'm not sure if it will show, but we might get a collision. No, we don't. But yeah, but we do actually have a collision. It just doesn't say. Right. Why is that? So if you move, if their size is 1, and you move the center by 1, you should be just touching the edge. So their size is 2. That means if we draw they're taking 2 units. So what happens if we move them by 5? 5. Okay. By 10, you should be touching the edge. Right. You're halfway there. Yeah. I mean, I think it's clear, but when the bird is... Or is this just the size? Is this actually the size of being 1? So we move by 10, we are kind of outside the screen because our screen is 20 units. And we move the center by 10 halfway. It's exactly there, and we have. So at size 1, we are taking up 2 units. Is this what's happening? Is this it? Where basically it's because of the aspect ratio maybe, or the camera. Where is Mr. Camera? Camera there. So we look at world up its Y. Yeah, like let's draw the let's draw the bird game. That's the bird collider. Let's draw the bird, but let's put it at collider 1. Let's reset this guy. Wait, what? Bird sprites, bind. Yeah, so essentially, I think, regardless of the Mr. Bird here, the idea is, I believe, so we have a unit of 2, maybe. Where's the bird? So, oh yeah, it's going behind this guy. Store it at 1. Don't need this, but we need to move column 1 dot position read write set z to 4.5, and then let's again set it to 4 as it was. So this is the default size of the bird before we shrink it, and it takes us 2 units of movement to get it to the edge. So that means I'm not sure if the camera affects this. I guess we can test, but we need to move 2 units for us to get outside. That means by default, what do you call it? Our sizes were wrong, I think. So when we say that we have a width and a height of 1, that's wrong. It should be a width of height of 2. I believe so. So we can test it with, because our collisions were not working. Right now we set the width and height to be 1. That's our kind of unit length. Let's move by 1 unit, so we'll be halfway. So even with this much, it's not considering this to be a collision. You can see on the top left, it says on the console says false, right? There is no collision. If we move a bit more, or maybe a bit less, 0.9, there should be collision. Yeah, true. Because our colliders are half the size of what they should be. Now, if we do 2 here, even at 1, even at 1.1, actually, we should collide. There we go, true. Let's do at 2, so we're barely touching. I don't think this will be a collision. Yep. And then at like 1.999, this should be a collision. There we go. Now we have proper collisions, I think. Now if we go to the to Mr. Bird, so the pipes should also have 2. And then collider birds box. Now whenever we touch, we should see. There we go, perfect. These are the collisions. Okay, I need to read more, honestly, on this to understand what's happening, like how many units this is. So at the scale of 1, out of the screen, how much space is being taken. Right now, at the scale of 1, with this camera, we're taking 2 units. But yeah, at a different size, we might take like 1 unit or 3 units or whatever it is. I think it's right to the camera. Left and right. Let's say the right is only 5. Does this and let's move them by, where's our test boxes? We move by 2.1, they should be just separated. But with the new system, let's see if they are. Well, let's do a 2. They should be touching. Yeah. Okay, still works perfectly actually. The collision works fine. So what if we hit this one as well? Top is 5. Yep, colliding fine. So I'm not sure what affects this, but I got to check. For now, let's continue the finish up this quickly. Should be easy now. Yeah. So we're visualizing the collider's fine, but our calculation was wrong because of the width and height. How many units we assume the width and height to be. That was the thing. Now, how do we know? There should be a way for us to know what. I don't think we're actually visualizing them right. That could be another issue. Because when we visualize the collider, we are not taking into consideration width and height, which makes no sense. So I think so that must go in, but I'm not sure how. I'm not sure how. We want like we draw a bird and then its collider. We're using the bird collider size, but this size is updated every time we move the bird, right? Yep. We set it to the position of the bird and the scale of the bird. But we don't consider width and height when we show it. Then how do we show that? Because it's drawn in the center. So this. This is not it, but like one thing we can do just to check is when we draw the birds, we can draw another box that's offset by width and height. So instead of a box centered at the center, the box would be centered bottom left. Yeah. Yeah. Actually, this might make more sense. Anyway, let's put it to do because I want to look into this. To do, let's see. Scale of 1 gives objects that span 2 spatial units. How is this determined? That's one thing. And then to do, way of displaying colliders that takes into account their width and height. Okay, for now let's just do the collision part. So collision in this case is easy. We just need to loop over all the pipes. And then we say, well, if we're not colliding with Mr. Pipe here, we can just continue. Otherwise, game lost. Right? So what does game lost mean? Let's have a game state. It's done a lot. No. Game. Type game state it's just an enum. So game state, say just for now playing, we just have two. And then game state, for example, lost. That's it. Okay. Now start is all the same, everything is okay. Just our updates. Now we can do a switch on, we need a variable as well. Current game state. Or we can just do a small game state. Is game state that starts as playing. And then start game state. If it's playing, we can run a function. If game state is lost, so all of this falls under func game playing, right? And check collisions. You can just come here, right? And if the bird collides with anything else, all we need to do for now is say, well, game state will still render the frame for now, right? Like we'll render the frame. The next time we the update runs, we're going to run a different function that does something else with the game, which won't move the bird, nothing. It will basically pause the game at that point. So game state is lost, right? Now we'll have a playing function. We'll also have func lost. And then this guy will just start playing, this guy lost. And in lost, what do we do? We can do I'm GUI. Mr. I'm GUI, it's been a while. I'm GUI.text. Where do we specify the, well, you lost. Now we can collide anywhere. So I'll hit this. You lost. Nice. How nice is that? We kind of have a game. Let's comment this. I like this code for visualizing colliders. All these things honestly need to be wrapped up somewhere nice instead of all of this. And we need the proper rendering system to make all of this easy. Because right now it's annoying, but that's fine. Okay. So how do we do Windows here? Forgot. We used to do is it just push? Push. because you can like all these window flags, no background. We want to tell IMGUI like, hey, okay, start a window, and here are my settings. Oh, I think it's just called begin. Yes. Begin group, whatever menu, but just begin. There's a window. Just do UI. Then we'll do end. Right. Right. Open. Yes, it's open. And then flags. Right. So I'm GUI. Window flags. So what do we want? Hide or like window flags. No background. And then no collapse. You cannot minimize it. And then I'm GUI dot window flags. No background. No bring. No resize. Yeah. No move. So I think these are nice. These are good enough. Open. Okay. Some other things we would want maybe is like a font size. I think this is done in the beginning of the game. By loading a font. nMage GUI. Add fonts. Yeah, we can choose a font here. I don't have a font here, but I think I have a project. GoPad, yeah, this guy has fonts. I just have one font here, but we'll have to do for now. So we can get the font, put it in Flappy resources. Let's have this. And then we can tell it, well, please resources, fonts, load this font. Size, we'll want something big, maybe 64. Font config, I guess I can pass a null. Don't care about anything specific. Yep, I can. Glyph range is also null, and we have an F. Yeah. Do I need to do anything with the fonts? Or is that it? This is one place to improve the API, so we need some comments here. You lost. Oh, so tiny. I can move it. So we need to position it as well. Right, that's one thing. And we need to remove this decorations, I think. No decorations. I'm going. Dot. Which font? All right. So we can set the fonts, and the font is imgui.fonts. imgui.fonts. And when we do this, so we begin the window, imgui.push fonts, do the text, imgui.pop font. Another thing is, wait, this is too long. Right. Position. Push item width. Okay. So what's the width? Well, we want the width of the screen divided by 2. So I'm GUI.window width divided by 2. And then I'm GUI.push item. Can we do height? Style bar, item spacing, not really. Window minimum size. Oh yeah, maybe this is a vec2. Well, let's do this. And this is not a float, this is a vec2. And dot window width screen. Of the current window. No, we want the full screen. nMage. One 280 by 720. There are some APIs that give us this. What I forgot. Okay, let's see if this does anything. So we're playing. Nope, I lose and I fail. What's wrong? Oh, I need to pop style bar. Okay, it's too small, but you know, somewhere, something. The other project had it, but now it's at least the text is kind of big. We have the all the decoration on the window is gone, but maybe we can use something from GoPad. So GoPad, please help us. So this is a project I'm using, building using nMage itself to do a text editor. nMage and I'm mainly. Now, when we do a window, editor. So editor has a render, next window position. All right, there we go. These two. So we do this before we begin. Okay. Draw size and window size. All right. Give me these, please. Update and draw. For us, I think the starting position is 0, 0. It says for it, I think it's, oops, wrong place. For I'm GUI, top left is 0, 0. So X is 0, Y is 0, and then window size. How do you get the window size? Win width. Where do you get win width? Oh, okay. Cool. 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 What do you mean G isn't clear? Game. What do you mean? What do you mean? Oh, okay. It's just hidden. So let's do var game is our game. Then we make them float 32s. Okay, then we begin the UI. I need for this. Okay. Oop, you lost. Nice. So position is 0, 0. So instead of it being 0, 0, we'll do the following. Position is this divided by 2. This is not exactly midway, but because if we want midway, if it's drawing from the center of the text, so we have the sentence drawing from the center. Actually, if it's from the center, it would be centered, I think. But it might not be drawing it centered. We'll see. Top. Yeah. Okay. Next window size. Window position. Position in the wrong place. Yeah. So the X position is not correct. Now we need the Y position, which we'll do here. Yeah. So it's drawing from the top left of the text. That's why it's skewed like this. But luckily, IMGUI does have calculate text size. So our text, let's do lost. Lost. Now this will give us vec2. We don't care about the height, so we'll just take the x. The x. So we'll do text width, and then let's see. So our position is offsetted by the text width by half it. Yeah, by half. This should look good. What's wrong? What is wrong? Hide text after double hash. False. Like count typing, no. Wrap width, we don't have wrapping, so yeah, really. I like the collisions are now really good. You lost. It needs to move more to the left, no? Yeah. Is it wrapping it? All right. We also need to set the bottom. So when we go down, we get this. Mm. Well, let's move it with the full. Kinda. Do it by double. Yeah, I think this looks good. Looks better. We really need all text size. And this guy, since we need to move it up a little bit. We need to do text size dot y minus, since it moves down when it increases, so we need to move it up. You lost. Yeah. Now it looks a bit better. Width is a bit weird in this case. Position. I assume text is being centered in the window. I hope it is. Text. Row text centered. I'm going. Oh, set cursor position. Right. So in here, set cursor relative to the window. So relative to the window, well, sir, we want to move by window width minus text width in half. Okay, go to 2w minus text size of text into 0.5. So yeah, I mean, it did look weird. Next position is really this guy divided by half. You need to have this oh, this looks good. Yeah, half each one of them. And what's the issue? Oh, next window position. This is not this is not the text position. Yeah. Next window position is just 0, 0. Then this works. Go. Window size, window position, and then so it's centered now. We were moving the window instead of moving the text alone. Okay, so we moved the text now. I think we'll do the same thing, essentially. Take this boy and do it on the Y and on the height. That's it. Let's go Flappy. Do it. Still kind of broken. maybe. Well, can we do a color? Push color. Yes, please. Let's make it maybe red. Texts. I'm GUI pop style. Maybe even make the bits a bit bigger. Oh, disappeared completely. All right, so XYZW, we want it to have full alpha, not be transparent. Come on, Flappy, where are you? Was falling all the way down. All right, I think, is this center? Calculations should make it center. Half the text and half the width, and then half the height. But yeah, I think this is good enough for today. Pretty good progress. We got some things to make it nicer. You can stop drawing colliders. Here we go. Now you have proper game, and oh, you lost. Okay, so thank you so much, everyone. Probably see you end of this week. Have a good day.